We focus to the mechanism in addition reaction part 2 based on to the second reaction we can call as a hydration. So in the hydration we have a 4 step. First, similar formation of carbocation, rearrangement to identify the most stable carbocation form, electrophilic. So I suggest this is similar for the mechanism before. So this is nucleophilic attack, and lastly the formation of the final product alcohol, the addition of hydroxyl group. So based on to the example 1, page 108, there are statement write the mechanism without the specific equation, but there already state this is the process of hydration, mean our reagent must be consist water and the presence of H3O plus as a catalyst. So for your information, this catalyst either dilute solution of H2SO4 or H3O4. So this is a dilute solution. Your catalyst can be write as a H3O plus in our equation reaction with a 2-methyl butene. So before we proceed to mechanism, compulsory please write down the chemical equation to predict either the major and a minor product can be formed or not. So starting from the nomenclature given, 2-methyl butene consists of 4 carbon atom. E means carbon double bond allocate at the carbon double bond number 2, and then carbon number 2 also we have a CH3 group. So fill up the hydrogen to ensure all the carbon should be achieve octet. So this is CH3 and this is will become CH. So the carbon here cannot be exist of the hydrogen. Okay, so this is a structure of 2-methyl butene. So it must be reacted with water molecule but in the presence of the catalyst H3O plus. So remember, the reaction take place must be follow the Markov-Nikov rule. Hydrogen atom in molecule water must be added first at the carbon-carbon double bond, but it must be added at the carbon number 2 because carbon number 2 consists higher number of hydrogen atoms. So we draw the first product can be formed. So this is hydrogen added, remaining hydrogen double will become single bond. So this is CH3, CH3, and a next stage we can find OH minus must be added. So the first tadi kita dah added H plus, so next step you must be added OH minus into the another neighboring carbon. So means our OH minus will added to the carbon number 3. So we can conclude this is a alcohol that consists hydroxyl group. So focus to the step mechanism. In a step 1, our reactant of the carbon-carbon double bond must be reacted with our catalyst because catalyst help the chemical reaction in reaction, but at the end of the reaction catalyst cannot be consumed. So if you want to produce a carbocation, means we must add hydrogen species into the carbon-carbon double bond. So from the one of the bonding pair in the carbon double bond here will attack one of the hydrogen atom, which is we can call as a proton. Okay, so next part, the bonding pair between O and H will disturb and electron directly give towards the oxygen because oxygen here is less of the electron, and we can trace the final product form, which is the intermediate species of carbocation should be added. So the final product we can draw CH3, CH from double becomes single bond. So this is we have a CH3 and a CH3. So we must know hydrogen here must be added to the carbon-carbon double bond. Follow the Markov-Nikov rule, means hydrogen must be added carbon number 2, while hydrocarbon at the carbon number 3 here will become carbocation. So now clarify the class of this carbocation. So it will become 1, 2, 3 alkyl group. So this is tertiary carbocation. And the same time, what happened to the remaining species form from the H3O+, it can produce a water molecule. So prove that. Right, this is the addition process, which is we add electrophile species first, which is H plus ion, into the carbocation. So is that we need to proceed step 2. So what happened to the steps 2? Step 2 is rearrangement. Is it rearrangement exists? So from the intermediate species, we already formed the tertiary carbocation. This is a more stable. So therefore, second step does not exist. So proceed the next step, nucleophilic attack. In part of step 3 nucleophilic attack, the tertiary carbocation must be reacted with our reagent water. While the step 1, the reaction occur between carbon-carbon double bond and H2O+. So we just have another reagent water, and this water will reacted to the carbon-carbocation. So the arrow full-headed must be from the lone pair at the oxygen toward to the carbocation, which must add the water into the compound. So finalize, the product can be formed as her CH3, CH. This is the first hydrogen added. This is CH3, CH3, and the new part here covalently bond with the molecule water. So this hydrogen atom will become positively charged. So we need the alcohol, tetapi air yang masuk. So in a step 4, our target is the formation of alcohol. So this alcohol, we can refer to our intermediate species, the area of alcohol, the presence at the H2O added here. So means the covalently bond between O and H must be break. So the reaction take place between this species and water that already eliminate in a step 1 here. Our target, we must produce H3O+ again, because H3O+ is catalyst. So lone pair of oxygen, use a full-headed arrow, attack proton, which is hydrogen, and the bond cleavage occur between O and H. Electron from bonding pair directly give toward to the O. So the product form CH3, CH2. I combine the two hydrogen here. CH3, and this is also CH3. And this carbon covalently bond with the oxygen H, and this oxygen has a 2 lone pair. And our side product, the catalyst of H3O+ form again. So that we can conclude catalyst cannot be consumed at the end of the reaction, but it can help the chemical reaction occur. But we know that the final product OH was formed. So we can conclude this is our group of alcohol.